So we're going to talk about Lewis structures, which are a way to visually show how atoms are bonded. When you draw Lewis structures, you're going to use valence electrons to bond the element because they're on the outermost shell of the electron, which is the only part that bonds in molecules. When you draw Lewis structures, you're going to use a dot for one valence electron and a line for two, just to show how they're bonded. One more thing that you're going to want to remember is the Octet Rule. And it tells you that every atom wants 8 electrons, except hydrogen, which wants 2 because it only has 1 orbital. And every element, except for hydrogen, wants to be like a noble gas because they are the most stable, and every element wants to be stable. So here you can see that oxygen has 8 because it has 2, 4, 6, 8 electrons. Nitrogen has 8, 2, 4, 6, 8, and then chlorine has 8, 2, 4, 6, 8. And those all follow the Octet Rule. So now let's draw one. Here are the steps. So first we're going to count the valence electrons. So hydrogen has 1 each, and there's 2, so we're going to do 1 plus 1. And then oxygen has 6, which would equal 8 valence electrons. Then you're going to arrange the atoms with the least electronegative in the middle. So you think the least electronegative would be hydrogen, except it is actually oxygen because hydrogen only wants 8, or does not want 8 electrons, and oxygen does, so hydrogen just never goes in the middle. So let's arrange them with oxygen in the middle and hydrogen on the outside. Then you're going to add lines to bond them, so bond hydrogen to oxygen and hydrogen to oxygen, and then make every atom have an octet. So hydrogen already has its octet with 2, and so we just have to fill out oxygen. So we're going to add 2 unpaired electrons to the top and 2 to the bottom. And then it says add double or triple bonds, but since hydrogen doesn't need extra electrons and oxygen already has an octet, we're done. And then we're supposed to count to see if we have enough. So 2, 4, 6, 8. That's 8, we're good. So you can also draw Lewis structures with polyatomic ions, which are a charged group of covalently bonded atoms. You basically draw them the same, except there's a few changes. So first, you're going to count the number of valence electrons like normal, like we did in the last one. We're going to start with ammonium, which is NH4+. So let's count. So nitrogen has 5, and each hydrogen has 1, which would be 4, since there's 4 hydrogens. Then here comes the different part. So if it is a negative, so if the whole polyatomic ion is a negative, you're going to add electrons, because if you have 4 protons and 4 electrons, and you get rid of a proton, so get rid of that, these 3 would cancel out, and you'd be left with an extra electron, which would make the whole thing negative, because there's 4 electrons and only 3 protons. But it's the opposite for positive. So if it's positive, you're going to subtract electrons, because once again, if you have 4 protons, and 4 electrons, and you get rid of an electron, these 3 would cancel out once again, and you'd be left with this extra proton, which would make the whole thing positive, and you'd subtract an electron because this one is gone. So ammonium has a positive, so we're going to subtract, which equals 8 once again. So the least electronegative is nitrogen, so we're going to put that one in the middle, and then the 4 hydrogens around the outside. And make sure they're pretty spaced out. Then we're going to attach a line to the nitrogen and the hydrogens on all 4 sides. And then you're supposed to make every atom have an octet. So each hydrogen already has its octet because it has 2 on each, and that one only wants 2. And then nitrogen also has its octet because there's 4 lines, so 2, 4, 6, 8. They're all done. Everything has what it needs, and there's no need for double or triple bonds. And then finally, to finish off this Lewis structure, you're going to put brackets around the structure, and then the charge in the upper right-hand corner. So the plus goes there, and then you're done with that one. Now let's try a negative one. So this is CO3 negative 2. Let's count up the valence electrons. So carbon has 4. Each oxygen has 6, so that would make it 18. And then it's negative, so we're going to add electrons. So we're going to add 2 electrons, which equals 24. Then we're going to put the most electronegative, or the least electronegative in the middle. So let's put carbon in the middle because it's less electronegative than oxygen is. And then the 3 oxygens on the outside. Then we're gonna connect them with lines. And then we're gonna add the electrons to the outside. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So we only need 2 more electrons. But if we add 2 here and 2 here, that would be too many. So this is where the double bonds come in. So if you make a double bond here, there's no need for electrons here or here, because now we have the right amount. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's enough electrons, so the double bond helps. Then finally, you're going to put brackets around the structure, like we did last time, and then put the charge in the right-hand corner.